So let's talk about dilutions. Now, we perform dilutions a lot actually in the real world. So a dilution is really just adding more water to something, right? So we're decreasing the concentration of the solute. So this is because the number of moles of the solute doesn't change, but we're actually going to increase the volume of the solution. All right, so for example, let's say you buy a concentrated juice that's in a can from the store. And in order to make that drinkable, you typically add more water. So we would dump the contents of this can into our pitcher and we'd add water. Now, the number of moles of juice in the can is going to equal the number of moles of juice in the pitcher. So only the volume of solution has changed, or the volume of water. So we can actually set up an equality between the moles of the solute before the dilution, so we'll call that mole 1, and the moles of the solute after dilution, so we'll call that moles 2. So those will equal each other. So again, mole 1 would be the juice in the can, and mole 2 would be the juice in the pitcher. Now, the moles of solute in a solution is actually equal to the molarity multiplied by liters. So we can set those equal to each other. So the molarity of solution 1 times its volume is equal to mole 1, and then the molarity of the second solution times the volume of the second solution is equal to mole 2. So we can rewrite this as M1 times V1, so the initial concentration times the initial volume, is equal to a final concentration times a final volume. So, for example, let's say before dilution, we have about 50 milliliters of solution, it looks like, and we have a certain number of moles in that solution. Now let's say that we add water. So now we have about 125 milliliters of solution. We still have the same number of moles, but they're going to be more spread out because we've added more liquid. So the concentration is going to decrease because we have the same number of moles of solute, just a much higher volume in the denominator. Okay, so let's use this equation in an example problem. So let's say we have a 125 milliliter sample of 0.9 molar NaCl. So that's moles per liter. And we're going to dilute that to 1,125 milliliters. What is the final concentration of the diluted solution? All right, so let's just list out everything we have. So we initially started with a volume of 125 milliliters. So we'll call that V1. And our initial concentration was 0.9 moles per liter. Then we diluted the solution to 1,125 milliliters. So that's our second volume, or our final volume. And then we're trying to solve for the final concentration, M2. All right, so again, in our initial solution, we had a volume of 125 mils, and the concentration is 0.9 moles per liter. But we're going to add liquid, and our final volume is 1,125 milliliters. And we want to figure out what is that new concentration. So let's just plug that into our dilution equation. Oh, whoops, I wrote V2. I meant V1. M1 V1 equals M2 V2. All right, so we've got 0.9 moles per liter times 125 milliliters. And we're solving for the final concentration, so we'll leave that as a variable. And the final volume is 1,125 milliliters. All right, so it looks like we're going to need to isolate M2. So let's just divide both sides by 1,125 milliliters. All right, so milliliters will cancel. And let's see, M2 is equal to 0.9 moles per liter times 125 divided by 1,125. Okay, so let's plug that into our calculators. And we should get 0.10 moles per liter. All right, so let's compare that to our initial concentration and make sure that we did in fact decrease our concentration. So it looks like we went from 0.9 to 0.1. So we in fact did dilute our solution. It's always good just to double check that we did the calculation correctly. So let's do another practice problem, and this time I'll let you solve it on your own first. So a 0.885 molar solution of potassium bromide, whose initial volume is 76.5 milliliters, has more water added until its concentration is 0.5 moles per liter. What is the new volume of the solution? So again, see if you can solve this on your own first, and when you're done, we'll go over it together. Okay, so let's list out everything we were given. So we were told that the initial concentration, M1, is 0.885 moles per liter. And then the initial volume was 76.5 milliliters. And then we're told that the second concentration, or the final concentration, is 0.5 moles per liter. And we want to figure out what is the final volume, V2. All right, so let's plug that into our dilution equation. So 0.885 moles per liter times 76.5 milliliters is equal to 0.5 moles per liter times V2. All right, so we're trying to solve for V2, so let's divide both sides by 0.5. So we'll get rid of 0.5 moles per liter on the right, and we'll end up with it on the left. So it looks like moles per liter, or molarity, will cancel, and we'll be left with milliliters. So let's just rewrite this. So V2 will equal 0.885 times 76.5 milliliters divided by 0.5, and then we already canceled our units there, so let's plug that into our calculator. So we should get a volume of 135 milliliters. And that makes sense because since we're diluting the solution, we should add more water. So we do have a higher volume than we started with. All right, so hopefully not too bad. Dilutions are actually pretty easy. Next time, we're going to talk about a new concept called chemical equilibrium. So I will see you then.